Hello, folks. This is Jeffrey Fox again, and we're doing the Big Data Applications and Analytics course, Data Science Curriculum, School of Informatics and Computing, Indiana University. And we're in Lesson 12 of the course motivation, which is Unit 2 of this 33-unit course. This, I think, is the longest unit because it covers everything at a very superficial level. And now we're going to look at web search and information retrieval as one of the major commercial examples. Remember, we've done so far as examples, three major examples: physics, recommender engines for e-commerce and movie and media sites. And now we do the other major commercial area of web search. The ones we haven't discussed are network sites like Facebook and things like that. Twitter is actually has some relationship to this because produces text. All right, so what are the types of things involving if you were doing the analytics for web search and so on? Well, you need to get the data. That you have to get it from the web, or you have to scan it all in like Google Books. So that means you need to crawl around all the whole web, and that, as far as I know, is non-trivial, but effectively solved problem. And of course, you have to do it in a responsible fashion, and people who tell you not to do it, you have to observe their interest and so on. Anyway, it just requires a lot of robots trundling out there to the web, gathering data from sites, and bringing it back. When you get the data, you need to run it through pre-processing, which do two things. They, of course, look for new links, which are new links to data that you check you have. If you haven't got it, you go out and get it again. Of course, you also have to update your data continuously. And you look for, when you pre-process the data, you look for things that people are going to do queries on, words and their positions. So you can do phrases. You want to record the positions of words. You form the so-called inverted index, which maps words to documents, so that when you're querying for a particular word, you immediately get the list of documents that have it. You quantify the sort of value of that word match, and that has two or three important aspects. One is the classic information retrieval thing called TF-IDF. TF is term frequency, IDF is inverse document frequency, which ranks the things depending on how often it appears and the relevance of that document. And that's used to quantify the importance of the word match. My inverse document frequency is how many documents this particular word appears in. TF is how many words appear in a particular document. Then we try to look at the relevance of documents here, where things like PageRank comes in, which effectively counts how often this and in what fashion a particular page is pointed to with links. Of course, you could, in principle, also look. You probably have data on how many users access this site. Then we have lots of advertising technology because you want to do the best job you can in supporting adverts, because adverts are how you get your money. Remember, I told you at the beginning of all this search stuff, nobody knew how to make money, but then people realized it was just advertising. You have to do a lot of reverse engineering so that you make your site very attractive for a search engine, so you get lots of people coming to your site, which gives you lots of money from the advertisers on your site. And of course, the search engines are doing the prevention of reverse engineering and punishing you for doing that. Then we need to do more sophisticated things, like I mentioned earlier, like latent factors and topic analysis, which is typified by Google News and other such things, which aggregate data, websites in a particular according to they're being related together. It's effectively a generalized clustering. All right, so that's web analytics. But it's pretty well understood now and relatively mature, except for these more subtle things like advertising. This particular picture is a well-known one from Wikipedia, which shows you each happy face is a web page. Here's a yellow web page and a green web page. And this, the finger pointing means there's a URL from here to here. And you will see that there are more finger points at the yellow than there are at the others. And PageRank measures not only the number of finger points, but it weights the finger points by the importance of the page. So the yellow one has the most finger points. This big red thing here only has 1 point, only from the yellow. But the yellow is such an important page, the fact that yellow points to the red makes it important. Anyway, you will see various sizes here, and that's just proportional to PageRank for this little 1, 2, 3, 4, 5, 6, 11 collection of 11 websites. PageRank is a very well understood technology, and of course is implemented with today probably in a very sophisticated fashion, hidden deep inside Google and Microsoft and Bing and Yahoo, who will never tell you what they really do. All right, so if we want to look at the application of recommend assistance to web page, this comes from a Yahoo tutorial. You're trying to effectively maximize. I told you, everything in life is an optimization problem. So when we're designing web pages, especially for portals or news pages, we're trying to optimize money. Because you could also try to optimize giving information to people, but that's not, that is straightforward. You just put the information on the page. But we're trying to do it in a way that optimizes money, and that money comes to various sites. Namely, there is somebody who owns the website, but if that website actually allows you to buy something, that's going to give you money to the person who sells it. So you have to serve the right item to a user for the given context to optimize your long-term biggest business objectives. And you need to do it in a way that makes the user happy, and so that you recommend sensible things because you want the user to come back. And because then they will spend more money and so on. So this is a scientific discipline. It has lots of things building it, large-scale machine learning, which is closely related to statistics. Then you have online models, real-time models, streaming models, and you have batch models, which are looking at the overall structure. Like there's a difference between streaming clustering and batch clustering. And you need to do this in an exploratory fashion, and you need to do testing to find out how to do this. And everything has to be, in principle, dynamic. And this page needs to be constructed in real time, according to exactly what you know at this very moment in time. And you have lots of objectives, because up here we listed lots of objectives. Click rates, engagement, which is how long you stay. There's no point in if you users click but never come back. The money you get, the diversity that you don't keep recommending the same thing, and so on. We need to try to understand what the user is. We need to effectively calculate user profiles. You can see how valuable those are. So Google knows now so much about me. It's always making good recommendations, better recommendations than it used to, because it has a much better understanding of me. And of course, that's how all these modern systems work. And then we need to actually interpret intelligently the information and things we get, which is natural language processing. And that allows us to look at things like breaking news and topics and getting things which are relevant and so on. Here we're looking at a page where we need to apply these principles to. It's got a rich set of, it's a typical portal page with advertisements, lists of different types of things. And we all have to decide what to put here according to this multi-objective optimization. And the next, if we just go through the animation, we can see that here we're recommending applications. That's the set here. Here we're recommending search queries. Here we're recommending packages. And with an image, title and a summary, and a link to other pages. Here we have links to other pages about octopuses and related concepts, cup winners and losers, which they think I might be interested in. And if we go through this, we can see that here in this area here, we have 4 items. Those 4 items are chosen out of a group of 20. There's which typically is we don't want to have too many. That number, total numbers chosen on the basis of experience, and is all done dynamically again to help to make certain I'm happy, and I come back to this page because I find Yahoo very satisfactory and so on. And this is all routing traffic to other pages, because all these things are links to other pages, and those other pages are going to be very grateful to me. They might even pay me money if I click on this octopus picture and go and buy a car, or whatever that octopus picture is trying to make me do. So that's pretty important. So when I'm looking at this content, I need to have, in the simplest case, I have a content module, and I have an inventory of possible content, and then I can produce some bias that I'd like a certain type of content, and I need to recommend the content in some fashion that improves the overall rate of clicking on this module, so that people are pretty interested in this module. And then I manage to make the click improve, but I also have additional information downstream as I further click through, and I want to increase the value of these downstream utilities. There's no point in people clicking if they're not going to go and buy the car at the car dealership, if they're just going to. So we need to make certain we attract the right clicks. And I need to look at this in a simultaneous fashion. We looked at the previous page. It had lots of different components, and we need to optimize those components together as a single overall multi-objective optimization. So it's all pretty non-trivial.